This is 3.3, day 1, linear equations with two variables. So yes, this goes along with your text, 3.3 in the text, and you can see it's right at the top of your notes as well. Consider the following situation. Dorothy has a younger brother, Benjamin. The table below shows their ages over 5 years. Benjamin's age, when he was 1, Dorothy was 4. When Benjamin was 2, Dorothy was 5. At age 3, Dorothy's 6. At age 4, Dorothy's 7. At age 5, Dorothy's 8. If Benjamin's age is represented by x, so we're going to call this variable x, and Dorothy's age is represented by y, make a linear equation to find Dorothy's age given Benjamin's age. Knowing that I have this as my x, how do I get to my y? So linear equation, because yes, it does graph as a straight line on the Cartesian plane. If we were to put this on the Cartesian plane, that x, y, what you call coordinate axis, I call it the Cartesian plane. If we were to put that on the Cartesian plane, yes, it would go in a straight line. And the equation is, for every time I want to figure out Dorothy's age y, I would take Benjamin's age x and add 3. Pretty easy. So the first example that you have here, example number 1, says write a linear equation for the relationship between hours and minutes. Well, if I take hours, to get hours, I could divide minutes by 60. That's one way I could relate them. Right? The relationship between hours and minutes. Or I could say that minutes, total minutes is equal to 60 times the hours. So depending on if you want to solve for minutes or if you want to solve for hours. At least that's how I see it. Write a linear equation for the relationship between days D and weeks. So days would be like total days. You would take your weeks and multiply it by 7. So 7 times your weeks. So 3 weeks times 7 would be 21 days. Or if I wanted to solve for weeks, I could say take my number of days, like 28 of them, and divide by 7, and I would get 4 weeks. So depending on which variable you want to solve for. Mrs. Ford heated a liquid and measured its temperature. She recorded the results in the following table. Write a linear equation for the relationship between time t, and the liquid's temperature, capital T. Notice two different variables, same letter t, but in two different forms. Time would usually be on the x-axis, and temperature would probably go on the y-axis. But they are asking us to use small t, lowercase t for time, and uppercase t for temperature. So the starting temperature at time 0, I can see is 25 degrees Celsius. The change in temperature for every minute, well, this is adding 5 each time, it looks like. From 30 to 35 is adding 5, adding 5, adding 5. So the change in temperature each minute is 5 degrees Celsius. So my temperature of the liquid, capital T, to solve for that, I would take the change each minute of 5 degrees time each minute, but I would have to start with that 25 degrees to start with. So that starting temperature gets added on. And yes, you could say capital T equals 25 degrees to start with, plus 5 degrees each minute. So you could switch that because, again, addition is commutative, so that's okay. Another example, George rented a car from a company for a week. The table shows the rental charges. Well, if you drive 0 miles, the rental charge is $100. So you can have it for the week, you're just going to pay the $100. If you drive 1 mile, you pay $100.10. If you drive 2 miles, you pay $100.20. Probably getting the idea here. 3 miles, $100.30. 4 miles, $100.40. So the company has charged a flat fee of $100, right? A flat fee of $100. So a $100 flat fee means, whoops, it's our dollar sign's already there. You pay for that whether you drive a mile or not. Plus, it looks to me like it's 10 cents for every mile of travel. So the linear equation for C, the cost would be $100. You get charged no matter what, plus 10 cents per each mile that they're calling D for distance D. So I'm going to put the 10 cents times the distance D plus the flat fee of $100 second. I'm going to write it in that format. The total cost would be 10 cents a mile plus the $100 flat fee. I would like you to try these two on your own. Write a linear equation for each. Make sure that you're paying a particular attention to the variables that they're asking you to use. D and H in the second example there, and capital M, lowercase t in the first example. And that's it for today. We'll work more on linear equations tomorrow.